Myself, Dr. Dinesh Bhagwan.Hanchate from Vidya Pratishthan's Common Line Bajaj Institute of Engineering and Technology. We are going to learn today that is what is the software testing. Again, we will see some of the observations about the testing. The testing is the process of executing a program with the intention of finding the errors. That has been said by the mayors. And testing can show the presence of bugs, but never their absence also. These are the observations about the testing by the two scientists.
Now we will continue with the good testing practices. So avoid non-producible or on-the-fly testing. So we should avoid now on-the-fly testing. So we should not produce any errors again and again. So second thing is that the write test cases for valid as well as invalid input conditions, so that we can understand that which test cases are valid or which test cases are invalid. We have to make the chart of that and then go through this chart and then show it to the development team, testing planning team, and then you have to correct it through that. Thoroughly inspect the results of each test. When you bifurcate the invalid and invalid test cases, so inspect the results of each test cases. So you can understand that which test case is going to be useful or which test is going to be a bad one for us. As the number of detected defects in a piece of software increases, the probability of existence of more undetected defects are also increases. So this is the main conditions, or you can say the main objective, or you can say the main part of your testing, that if you increase the defects in a software, then you will find that the probability of the detected defects will be increased, because the defects has also got the number of defects which are being accompanied with that. Now, good testing assigned to the best people in the company, the people who are having a skillful, and also the masters in the coding, masters in the design and analysis. So throughout the SDLC, that is software development life cycles, they have got a more experience of having to find out discover the errors and bugs in the program. The intelligent people has to be there for having a testing, so that they will find the black holes of your programs. Note the point that testability is a key point in your SDLC. That's why the testability is a key point of SDLC. If you do something mistakes in your requirement analysis, then you do also the mistakes in your further analysis, higher analysis, and also do the mistakes in the design, and then you do the mistakes of send the mistakes to the coding, and then also the testing also. And testing has to take a rigorous testing from the reverse directions, from testing to analysis. Don't make the program easy to test. So you should not make a program so that by considering that you should have to make a test and then you should make the program very easy. Testing must commence with the objectives such that every other activities. So every other activities are there in your software development. So testing is also considered as just like a other activity. We see the level of testing now. That is, the first testing is called as unit testing. Then we will do the integration testing. Then we will have a validation testing. In the validation testing, we do the integration testing, alpha testing, beta testing, and fourth one is acceptance testing. So is the last one. These are the levels of testing we used to do in the software development. Let us see now the unit testing. Unit testing has got the various parts of the aspects. First is the algorithms, the unit of your programs are the algorithms, then logic, the data structures, the interfaces, the independent paths which is going from one area to the another area through the module, the boundary conditions which are required to go from one boundary to the another boundary of the modules, then error handling. So all these parts are all these parts comes under the unit testing. We'll see one by one in the next coming or forthcoming lecture. We continue with the integration testing. Interfacing errors not detected in the unit testing may appear. If you do the unit testing and then you go for the integration testing, and some of the errors which are being there in unit testings, we cannot discover it. We can discover it into the interfacing of the integration. That is, when you do the integration testing, we get the errors. Next one is the timing problems are not detectable by the unit testing. So if you do the unit testing, means each unit has been tested and then timing problems are there, especially in the real-time system software. So we get the problems, the timing problems, that is communication problems, and that's why we have to do the integration testing. Resource contention problems are not detectable by the unit testing. So resource contention problems. What is the contention problems of the resources? So if you are having some variables and the models and which are being connected with the resources, and the resources are being connected with these modules and then functions, and when you go to the testing by the unit testing, then you will come to know that every module is assigned to the correct resource person or resources which are available for the project. But we cannot find which resource person is going to be having in a deadlock situation when the program is going to run, when the software is going to run, developed software is going to run. So that can be identified by the integration testing. Ultimately, you have to use some of the algorithms of operating system to find out the deadlock and to find out the critical sections of your program. will go to the top-down integration. So what is the meaning of the top-down integration? The main control is there, the main model as you can see in the diagram, and used as a driver, and stubs are substituted for all the models directly subordinate to the main model. So main model is there and there are the sub-models are there and the stubs are there with the things which has to be integrated to be given to the all the models. The stubs may be given all the functions or sub-functions and which has been integrated into the M1 and M2, M3 in this way, the model 1, model 2 in this way, and we will integrate into the main part from top bottom integration. So the main control model is used as a driver and stubs are substituted for all the models and directly subordinate to the main model. So subordination is going through the main model. Depending on the integration approach selected, depth or the breadth, subordinate stubs are replaced by the models one at a time. So depending on the integration approach selected, now there are various approaches of integration. Integration of 2 modules, integration of 3 modules, integration of 4, 5 modules, integration of variables, integration of the procedures. So it is maybe the approach of a depth integration or the breadth integrations. You can see the tree now. So the tree indicating that there is a labels of a tree and also the depth of the tree and also the breadth of the tree. So you can integrate model 1 to the model 2, or model 3 to model 4, model 6 to model 7 in this way also, and you can integrate the model 1 to the model 2nd of the 3rd level, 4th level, 3rd level also. So all these integrations, if you do it, and stubs are replaced by the models one at a time. What is the meaning of this? Subordinate stubs are replaced by models one at a time. Subordinate stubs are replaced by models one at a time. Means every time you are pushing some models into the stubs, which are the particularly models dedicated to the particular stubs, and we do the integration of that, and then again the next model will come and replaced by the stubs again. So this is called as a top-down integration. The top-down integrations we will see now, the tests are run as if each individual model is integrated. So tests are run as if each individual model is integrated. On the successful completion of a set of tests, another stub is replaced with a real model. Tests are run as if each individual model is integrated. We have to suppose that all the models which are being there, if you do the part of the models which are being there, you have been integrated and then you are testing it. You have to suppose that the models are integrated and then you have to test on that. On the successful completion of a set of tests, another step is replaced with a real model. So meaning is that the common type of the test cases are being put into the software, and then another stuff will come and then common type of test cases I'm saying, we will put into the stuff and then we will check it that whether the model which has been put into the stuffs are correct or not. Making sure that the regression testing is performed should not impart the errors as a result of integrating new models. What is the regression testing? We will see in the next part. Many times calculations are performed in the models at the bottom of the hierarchy. It may happen that you are making the calculations right from the bottom and then you go up to the top and then you do the calculations, how many errors are there, how many bugs are there, and which are the depth of the errors are there, what is the risks of the errors is there. Stubs typically do not pass data up to the higher models. Stubs are not going to pass any data to the higher models. So the delaying testing until lower level models are ready usually results in integrating many models at the same time rather than one at a time. So if you are delaying in a testing of the lower level models, then that is going to be difficult for us at the same time rather than one at a time. Developing a stubs that can pass data up is almost as much work as developing the actual model. So if you are developing a stubs and along with the data if you are passing it, is almost such as we are developing one of the modules.